This video is for section 13.2 about liquids. Learning goals are to know the causes of the physical properties of a liquid and to understand evaporation, dynamic equilibrium, and boiling. Let's look at that first learning goal. What are the causes of the physical properties of a liquid? Physical properties of liquids are caused by the motions of the particles and the forces of attraction between the particles. Now, some physical properties of a liquid are viscosity. This word refers to the liquid's resistance to flow. So a liquid with a high viscosity is really thick. It doesn't flow very well. That'd be like syrup or tar, honey. A liquid with a low viscosity flows easily, like water or gasoline, fingernail polish remover, which is called acetone, vinegar. So a lot of liquids have low viscosity. They flow very easily. Another physical property of liquids is that liquids have surface tension, attractions between the particles at the surface of the liquid. Another property of liquids is a liquid has a certain temperature at which it boils. This is called the boiling point. And a liquid has a melting point, a temperature at which the solid form of the substance melts and turns into a liquid. And finally, another property that you've heard of is solubility. Solubility refers to the ability of a liquid to dissolve into another liquid. Now, in this lesson, we're going to focus on just a few of these properties. One is the ability of a liquid to vaporize. This process of vaporizing is called vaporization. This is the conversion of a liquid to a gas. A substance can vaporize. This means that the particles of that substance have enough kinetic energy that they overcome the forces of attraction to the other particles of the substance. When that happens, some particles of the substance will, in a sense, float away. They will escape from any attractions that they have to other particles of the substance. Take a look at this animation. Here we're seeing a model of a bunch of water molecules. The hydrogens and the oxygens, the little bent shape. These water molecules have attractions to each other because they're polar molecules. Also, there's some hydrogen bonding going on. But notice that occasionally in the animation, some of the molecules have enough energy that they escape and float up above all of the rest of the molecules. That process of a molecule obtaining enough kinetic energy to escape from attractions to the other molecules is called vaporization. A related term is evaporation. This is vaporization that occurs at the surface of the liquid. And that's sort of what we were seeing in that animation. The molecules that seemed to float up above were coming from the surface of the liquid. Another vocabulary word is vapor pressure. When a liquid vaporizes in a closed container, the vapor particles will collect above the surface of the remaining liquid. As these particles move around, they will collide with and exert pressure on the surface of the liquid. This is called vapor pressure. Let me make a quick sketch. Here is a container. And I said it's a closed container, so here is a lid on the top. Now in the container, there is liquid. Let's say that this is the surface of the liquid, and here are a whole bunch of the actual particles of the substance. Millions and millions and billions of particles of this substance. The substance that I drew in the container is in a liquid state because of how the particles are being attracted to each other. They're not so strongly attracted that they're sort of locked into position like a solid, but there's enough attraction that they're being held together in a definite volume. The particles can flow around each other, but they can't just fly up into the air above the surface. Now, if some of the particles do obtain enough kinetic energy that they can escape from attractions to the surrounding particles, then some of the particles will start to float above, and they will collect up here in the top of the container. As the amount of particles build up in the container, they will occasionally collide with the surface of the container. And every collision exerts force upon the surface of the liquid. That force can be measured and it is called vapor pressure. Another vocabulary term is dynamic equilibrium. This is the condition in which the number of particles turning into vapor is equal to the number of vapor particles turning into liquid. What does it mean to say that particles are turning into vapor or particles are turning into liquid? The particles themselves aren't turning into anything new. What this is getting at is the attractions between the particles. To say that vapor particles are turning into liquid really means that the particles of the substance are starting to experience attractions to other nearby particles. When those attractions are of sufficient strength, particles are no longer able to move around freely from each other. They will start to flow past each other, but still stay within a definite volume. That's the liquid state. Let me draw a diagram of what this idea about dynamic equilibrium is all about. Let's say we have a container, and in the container there's a liquid. This will represent the surface of the liquid. Remember what a liquid is. It's just a whole bunch of particles that have attractions to each other, but not so strongly attracted that they can't move around. That would be a solid. And let's say that above the surface of the liquid, that some of the particles of the substance are more freely moving around. These dots that I'm drawing up above the surface represent the vapor particles of the substance. As time goes by, several of the vapor particles may lose some kinetic energy, and when they become attracted to all the particles I've drawn at the bottom of the container, they will rejoin that mass of particles and become liquid. However, at the same time that is happening, some of the particles that are in the liquid may gain enough kinetic energy that they're able to escape from the attractions of nearby particles and float up here up above as vapor particles. When the number of vapor particles turning into liquid is equal to the number of liquid particles that escape as vapor, that condition is called a dynamic equilibrium. Let's do some check for understanding questions. I'll pause the video for you to answer. And here are the answers. Question 1. What happens to the rate of vaporization of a substance when the substance is heated? It's going to increase, because when the substance is heated, the particles of that substance gain kinetic energy. As they gain kinetic energy, more and more of them will have enough kinetic energy to escape from attractions to nearby particles. And the particles that escape from those attractions will float up above the surface of the liquid. Question 2. What happens to the vapor pressure of a substance in a closed container when the substance is heated? The vapor pressure is going to increase for the same reason. So when the substance is heated, more of the particles that we call liquid will be changed into particles that we're going to refer to as vapor. An increase in vapor particles means there will be more collisions with the surface of the liquid. More collisions is a greater force applied to the surface of the liquid, and that means a higher vapor pressure. One reason we study vapor pressure is because it's a good indicator of the volatility of a substance. A substance that isn't volatile does not evaporate easily. If a substance doesn't evaporate easily, then not a lot of the substance is going to turn into vapor. Then there's not going to be very many vapor particles above the surface to apply pressure to that surface. There'll be a lower vapor pressure. On the other hand, a substance that is highly volatile evaporates easily. Think about what it means to say that a substance evaporates easily. Particles of that substance easily change from liquid to gas form. If that easily happens, then more vapor particles will start to build up above the surface of the liquid, exerting a greater pressure upon the surface of the liquid. Here's another check for understanding question. I'll pause the video for you to answer. And here's the answer. At 30 degrees Celsius, the vapor pressure of water is about 5 kilopascals, but the vapor pressure of gasoline is about 40 kilopascals. At this temperature, how many times more volatile is gasoline than water? Take the vapor pressure of the gasoline, 40, and divide by the vapor pressure of the water, 5. 40 divided by 5 is 8. If the vapor pressure of gasoline is 8 times greater than the pressure for water, that means it's 8 times more volatile. If gasoline is more volatile than water, then gasoline evaporates faster. Let's say you spilled a gallon of water on the floor, and then right next to it you spilled a gallon of gasoline on the floor. The gasoline is going to evaporate faster into the air than what the water will. The gasoline puddle is going to dry up much quicker than the water puddle. Okay, now number 2. Did you know that areas of the country in which there are large temperature changes between winter and summer, and Michigan certainly is an example of this, that these areas have different mixtures of gasoline for winter and summer? In the winter, gasoline needs to have a higher vapor pressure so that it vaporizes easily enough for engines to start in cold weather. But in the summer, gasoline needs to have a lower vapor pressure so it doesn't vaporize as easily. Summer blend gas happens to contain 1.7% more energy than winter blend gas. So the question is, which gasoline blend gives better gas mileage? Well, that would be the summer blend. Because summer blend gas has more energy contained within the gasoline. With greater energy, your car is going to be able to drive more miles per gallon of gas. The next vocabulary word is boiling point. Boiling point is a temperature. It's the temperature at which particles in a liquid have sufficient kinetic energy to vaporize. A substance boils when its vapor pressure exceeds the external pressure on the surface of the liquid. For example, the reason that the boiling point of water is 100 degrees Celsius when the surrounding atmospheric pressure is 101.3 kilopascals is because at that temperature, the particles in the liquid water have sufficient kinetic energy to escape attractions of the other water particles and to overcome the force of atmospheric pressure that works against particles escaping from the surface of the water. So that was a really long paragraph, so let's make sense of that. I'm going to draw a diagram. Over here on the side, here is a container. This is an open container. I'm not going to put a lid on it. Now right across here, let's make believe this is the surface of some water. And again, what is liquid water? Just a whole bunch of particles. They're all really, really close together, right? Just flowing around down here. Now above the surface is the atmosphere, right? The air. That air exerts pressure upon the surface of the liquid, and that is called atmospheric pressure. To vaporize, the particles in the liquid have to not only overcome the attractions to each other, but they have to push against that downward force from the atmospheric pressure so that a particle can escape and pop up here, float around up there as vapor. For this to happen, a certain temperature has to be reached that will depend upon the substance itself. In the case of water, when there is 101.3 kilopascals of downward atmospheric pressure, that temperature happens to be 100 degrees Celsius. The boiling point of water is the temperature at which water is able to vaporize. The boiling point of a different liquid is going to be some number that's different than 100 degrees Celsius, because a different substance than water is going to have different strengths of attractions between its particles. If external pressure is increased, then the boiling point of a substance increases. If the atmospheric pressure was more than 101.3 kilopascals, so a greater downward force against the surface, it's more difficult for particles to escape from the surface of that liquid. It's going to take more heat energy for that to happen, and the boiling point temperature is going to increase above 100 degrees Celsius. This occurs in a kitchen device called a pressure cooker. And some of you have a pressure cooker, or you have the modern version of the pressure cooker, like an Instapot. When food is cooked inside a pressure cooker, the boiling point of the water that's in that pot is higher than 100 degrees Celsius. The water that's in the pot that's cooking the food is hotter than what we would consider the normal boiling temperature for water. so that water carrying that extra heat energy is able to cook that food faster. This concludes the video about properties of liquids.